Have you ever wondered how long you could endure in a place without clocks, calendars, or sunlight? French scientist Michel Siffre risked his life to answer this question, descending deep underground. His goal was to discover how the human biological clock functions when completely cut off from the outside world. This radical decision not only changed his own life, but also transformed science's understanding of time and biological rhythms. 1962, a groundbreaking experiment at the age of 23. At just 23 years old, Michel Siffre decided to descend into a cave 130 meters below Scottisson Mountain. In this dark, damp, and silent environment, there were no clocks or calendars. His only contact with the outside world was through radio transmissions, a few times a day, to report his condition to his team. He brought only basic supplies, a flashlight, and a few small tools. When the experiment began on July 16, 1962, Siffre was waging war against humanity's greatest adversary, uncertainty. His mission was to understand how the human biological clock functions when completely cut off from the outside world. Time begins to slip away. At first, everything seemed normal. Siffre ate, slept, and woke as usual. But as days went by, he noticed something strange. His sleep-wake cycle began to drift. His body slowly abandoned the 24-hour rhythm and shifted toward a 25-hour cycle. Even more striking was the distortion in his perception of time. According to his notes, when he tried to count 5 minutes, it felt like only 2 minutes had passed. In other words, his mind was running at half the speed of real time. Each day began to feel longer than the one before. Days blurred together, and he lost track of when he had awakened or how much time had passed. The price of 63 days of isolation. Siffre had planned to leave the cave on September 14, but when he surfaced, the calendars showed only August 20. For him, 63 days had passed, while in the outside world, only 38 days had gone by. This dramatic difference revealed just how fragile the human mind and biological clock truly are. Upon emerging, he faced another problem: extreme sensitivity to light. His eyes had grown unaccustomed to daylight, making it almost unbearable. It took weeks for him to readjust to the outside world. Contribution to science. Siffre's experiments eventually gave rise to the scientific field known as chronobiology. He demonstrated that the human body has an internal rhythm that can function independently of external cues like sunlight and clocks. Decades later, his work inspired research that earned Jeffrey C. Hall, Michael Rosbash, and Michael W. Young the 2017 Nobel Prize in Physiology or Medicine for their discovery of the genetic mechanisms of biological clocks. NASA also relied on Siffre's findings to study how astronauts perceive time in space. Further experiments. Losing time again. Siffre's curiosity did not end there. Years later, in 1999, he entered another cave to celebrate the new millennium. He wanted to see how his perception of time had changed with age. Once again, the results were astonishing. He thought he celebrated the new year on January 1st, but in reality, the date was January 4. This time, he spent 6 months underground. Despite sinking into a deep depression from loneliness and timelessness, he made an important discovery. The human body could adapt not only to a 24-hour cycle, but even to a 48-hour cycle. These experiments were not only biological tests, but also psychological ordeals. Isolation, loneliness, uncertainty, and timelessness were powerful forces that challenged the human mind. Although Siffre endured significant psychological strain, he succeeded in revealing the limits and flexibility of the human brain. A lasting legacy. Siffre's work left a profound mark not only on science, but also on everyday life. Today, our understanding of jet lag, the impact of shift work on sleep, and the health consequences of sleep deprivation all trace back to his pioneering experiments. His courage showed us that the human body and mind are far more adaptable than we might imagine. Time may appear to us as a fixed concept, but Siffre's cave experiments proved that our perception of time can be rewritten by the brain itself. In the end, Siffre's cave experiments were not just scientific studies, but also a profound struggle between humanity and its own nature.